titrating. Whoa, what happened to that? There. What the heck is going on here? I got shut off. Oh, it's going. Okay, we're going to wrap up titrating. So just like on the quiz, what we did is we identified what's going to be present at the equivalence point after all this base reacts, and you got to stop adding it right when all the, like if we're titrating a weak acid with a strong base, stop adding that strong base right when all that conjugate acid reacts, right? You better stop. And then don't go a drop over. So that all that's left at the equivalence point at that point is the conjugate base. So then you have to write a Kb reaction. We do ice, and then we get the pH. So that's what we're going to do today. We're going to finish the whole story. But let's do a little practice first. And let's see if we're all on the same page here. So I'm giving you a titration, and I want to know what is the Ka or Kb reaction that's going to determine the pH, that's going to dominate, that's going to control the pH. So let's start with Kendall here. I'm titrating HCN with NaOH. So Kendall, are we going to write a Ka or a Kb reaction? Kb, good, because we're titrating with a base, you're going to get a base. So she's exactly right, Andrea. What is the Kb reaction we're going to have to write? What goes to what? Cn minus plus H2O, perfect. HCN and OH, perfect. Okay, that's what we're after. And then we'll calculate the initial concentration and do ice. But we're just practicing getting set up. Because Kenneth, if we go through all this work and you don't have it set up right, and all that was wasted energy. How about a titration of HF with NaOH? What reaction would you write that's going to dominate the control the pH?
Kb reaction.
It's going to be Kb, perfect.
So negative F plus H2O.
F minus H2O.
HF plus OH.
Perfect. I think one more here. Now I'm trying to confuse things here. Enrique, I'm trying to confuse things here. Because remember, you have all these tables. You've got these weak base tables. You've got these weak acid tables. So here's another one. Titration of methylamine with HCl. A Ka or a Kb reaction? Without even knowing what methylamine is, it's got to be a Ka or a Kb reaction. It has to be a Ka because you're titrating with an acid. So whatever answer you give, it's got to be a Ka reaction. So Connor, Enrique gave you a hint. What Ka reaction is it going to be? Keep going. CH3NH2 is methylamine. So, right, you're on. You're close.
CH2 or CH3NH1.
Right. So you're on the right track. He's trying to write a conjugate. But are you supposed to write a conjugate acid or the conjugate base of this thing? Conjugate acid. How do you write conjugate acids? Yeah, you can put an H out in front, add an H anywhere. I like putting H's out front like Kendall said because then it's more obvious. But I think the book would probably write CH3NH3+. But I like putting the H out front. Because remember, bases, they grab an H. That's the whole purpose of them. So these are all bases. So let's put an H out front, like Kendall said. H, CH3, NH2 plus. Steph, how do you finish this Ka reaction? H plus. Yeah, go back to that methylamine. All right, so here is that methylamine if you're wondering where Connor got it from. All right. Okay. Here we go. So we're going to have a titration. And notice part B is find the pH at the equivalence points. We've got some steps here, but I think you've already done it before, but I wrote down the steps anyway. Let's go ahead and get this started here. Audrey, where would you start here? We've got 12 grams of acetic acid, and I'm giving you the Ka, so you have to look it up, dissolved in 50 mils of water, titrated with 2.8 molar NaOH. At the equivalence point, what conjugate acid or base is present? Oh, I guess first let's just answer this question. You're right, you're going to have to switch the grams for moles, but what conjugate acid or base is present that controls the pH when you do this titration? It's going to be a base. What is it going to be? How would you write its formula? Definitely it's going to be a base because you're titrating with a base. Good. What would be its formula? C2. Perfect. C2H3O2 minus. That's the answer to that part. Okay. And they want to know what its concentration is. So now we got to figure out the concentration of it. But I guess what I'm driving at is the homework may not even have you do this part A. The homework may just say, what's the pH at the equivalence point? Well, you got to do all this first. You have to identify what's going to be present. Then you got to calculate its concentration, right? I don't know if you heard Audrey, what she said first, Jose, but she was starting to calculate this concentration already. She gave a suggestion. What's that? Get the moles. Okay, how do you get those 12 grams into moles? You can write, how do you get it into moles? Is it 50? 2 carbons, 4 hydrogens, and 2 oxygens adds up to be 50. All right. What's the molar mass of that thing? 4 hydrogens, that's 4 plus 24 is 28. It's 59. 58 plus 32. 59 or 60?
It's 12 plus 12, 24, then plus the 4, plus 32.
It's 60, isn't it?
Oh, yes.
One's a big deal. 60. All right. Isn't that how we go from grams to moles? Okay. Oh, let's see what I got there. 12 over 60 is 1/5. That's just 0.2, isn't it? Okay. Okay, now what'd you do, Alyssa? We got the moles. Oh, good. So how many liters would that be? 0.05. So what is that? Where does that liters go, Alyssa? Yeah, you're exactly right. I just wanted to make sure you remembered, right? Concentrations moles over liters, so 0.2 over 0.05, and we'll have our answer. Oh, no, we won't. Is the volume 0.05? I almost screwed up. What did I forget? Yeah, because is the final volume 0.05 liters? we have to add on that number, right? See, it's getting in this little mode. I forgot. You know what I should have done? I should have done this. Like when we said concentration, this is what I should have wrote. Shoulda. I should have wrote moles all over total volume. Then I wouldn't have screwed up. Remember, that's what we did last time. Or total liters, if you like total liters better. Because then I would have remembered, oh yeah, I got to add on some volume here. So that volume we're adding on, why are we doing this again, Bowdy? What volume do we have to add? The volume of the NaOH, exactly, because we titrated it. I forgot. Okay, so how do we figure that out?
We use the big M of it.
Use the big M equation. Okay, so I can set up the 2.8 big M equals what over what? Moles over the. What do I put in for the moles? This number, don't I?
Yeah.
Right, they're all the same. And I solve for those number of liters. That will go in there. So number of liters goes up on top, 2.8 goes to the bottom. So 0.2 divided by 2.8. I got about 0.071. Man, that would have really messed things up. That's a big number. So what did you get as a final concentration here? Did you get like 1.64 or something?
Yep, just that.
Yeah.
So when we're calculating the moles, kilograms to mole, that H, is it going to affect it at all? Because if we're doing concentration.
Oh, maybe that's what Kenneth was talking about. Because all we have is the acetate. You're exactly right. So, but the problem is they said we have 12 grams of acetic acid. I think you got to think of it this way. If you have grams of acetic acid, you have so much mass. But that grams isn't converted to grams of acetate. It's not still 12 because you lost that H. But the moles is the same. So the moles of that conjugate acid is the same as the moles of the conjugate base because moles is just number. If you got a dozen conjugate acid molecules, you're going to get a dozen conjugate base molecules. So moles is the number. So you have the same number of them. So we got to get this into moles, and then we'll have the moles of the conjugate base. And you're right, the conjugate base is C2H3O2, but the 12 grams is the acid. So this has to be HC2H3O2 because what we massed out was the acetic acid. If they would have said 12 grams of, oh, here's a good one. Well, that'll be the next one later. I don't want to confuse you. But 12 grams of the acid is what they massed out. So we should have an initial concentration of 1.64 molar of that base. Okay. So keep asking if it looks confusing. Now we find the pH at the equivalence point. This is going back, I don't know how many class periods, 3 or 4 class periods, and it's a homework question, right? We know the initial concentration. So what we're going to do is, we already did step 1, determine the concentration of the conjugate acid or base formed at the equivalence point. We already did that. We need to write the appropriate Ka or Kb reaction and do ice so we can get the pH. So we are going to write a K, everybody? B. Good. C2H3O2 minus plus water gives the conjugate acid and hydroxide. We have to do ice. All right. Let's see if Cameron remembers how to do this. How do you do ice?
You put all the ice, so you have I guess
All right. Here's the concentration of this stuff. That 1.64 is going to go where?
1.64.
Yeah.
It's gonna go under your top one right there.
Yeah. Under that acetate. That's what we calculated it for. Water, just put dashes or whatever. It never shows up. We put dashes over here. Do you write minus x and 1.64 minus x? Remember doing this? X's, positive x's. All right. But then what do we do, Kendall? Yeah, the KB equation, right? But what would that be? KB is going to equal,
You're not going to do the liquid system. It's going to be H2, H3 plus. Oh, it's negative.
yeah,
And then over C2, H3.
yeah. So Kendall's got it all set up for you. Andrea, now how do you plug in some numbers here?
So we would plug in x for the top two.
Yeah.
1.64 minus x
X squared, 1.64 minus x. And then, Andrea, what do you do for the KB?
You have to go for it in the table. Oh, no. I don't
Right? Because remember, all you're going to be given is this stuff. So here's a bunch of KBs, and you're looking for that acetate. There's no ions here at all. That's that one where you got to calculate them, remember? You got to look up the Ka for the acid, and then Kw over Ka is Kb. So for HCN, 4.9 times 10 to the negative 10. $1.4. Oh, did I? Oh, 1.7 to 10 to the negative 5. Oh, it's acid. I looked up it. Anyway. Thank you, Alyssa. 1.7 times 10 to the negative 5 is Ka. Kw is 1 times 10 to the negative 14. Oh, please get a 10 to the negative what? 10 to the negative, because otherwise you can't drop that x. Do you remember this game? You want a 10 to the negative 4, and that's cutting it. Or 10 to the negative 5, negative 6, negative 7, and then we can drop those that x, remember? So 1 times 10 negative 14 divided by 1.7 times 10 to the 5 negative. Decent. A 10 to the negative 10, that's perfect, right? All right, see if you can figure out the rest of this. You've got a KB of 5.88 times 10 to the negative 10. So which x can you drop again? The one at the bottom, because you're taking a big number, 1.64, minus an extremely small number that's on the same order as this 10 to the negative 10. It's still 1.64. So. Anybody get it? Get a final answer for the pH? 9.5?
Yeah.
Mia, did you get 9.5?
Yeah, so if I was using my calculator.
No. And remember, so you don't screw up, should you get a pH bigger than 7 or lower than 7?
Bigger than 7.
Bigger than 7 because it's a conjugate base, so it better be basic. So it's a quick catch. And what would you say the number was? 9.5. Okay. Take the log of the x and you have POH, subtract from 14, that's the easy way. Okay. So here's the answers are there, so see if you can get these to work out. And you have tables of KAs and KBs. So you have everything you need to figure these out. I'll be glad to help you. Okay. Focus, focus, focus.
I don't understand the whole acid base thing. I just don't
So
understand that.
if you titrate with an acid, that means this has to be a base. So if it's a base, it reacts with the acid and you get its conjugate acid.
So you're trying to get Ka.
So that means, yes, so you end up with a conjugate acid, so you have to write a Ka, exactly.
Okay.
So I guess that's what keeps me from screwing up. If I titrate with an acid, I have to write a Ka. If I titrate with a base, I have to write a Kb.
You gotta do all that stuff.
Yeah, now you got to do everything. You got to first identify what's formed at the equivalence point and calculate its initial concentration.
So you're
Then-
gonna have to do ice and everything.
Then you write the Ka reaction and do ice. Exactly. That's what I'm thinking. Most of the homework questions are going to look like this and not like the one we did. The one we did divvies it up into steps for you.
So they'll only do one of these on the test.
Most definitely. At least one. You see how to do this?
Yeah.
Anybody not sure what's going on here?
So once you get the molarity,
And
you
then
gotta
you,
find the Ka, put the Ka in. Ka for this.
well then you go do ice. So set up the ice table, and then this Ka has to equal, products over reactants. And then if you need then you get the Ka no matter how you get it. So I would just do one step at a time. Let logic dictate what you do, otherwise you might waste time. Because you're right, you're going to have to calculate that Ka.
Yeah. Sorry. So since it's Ka, actually, I don't have a question. I was trying to think because before these little things at the end of it, so the POH, we turned it into H by subtracting 14.
Yeah.
For this one, would you not do that? Since
See, there you go. This is what's going to kill you, Kenneth, is that you can get through the question really quick doing it this way, but you end up making silly mistakes, and it's going to bite you in the back. So, like over here, you're not sure. See how in my work, by writing that Ka or Kb reaction, see this? In the last problem you did, X is OH minus. So I knew X is, when I take the log of X, I'm going to POH. It doesn't take that long to write it, that ice table. Did you get an initial concentration of 0.12? No, you did great. Excellent. That's what I got to. What is it? KB for methylamine? Did you get final answer? But it matched, right? 5.7. Perfect. Yeah. All right, it should work. See if you can get 5.8 for the first one and 8.68 for the next one. If you can do these, I think you're totally ready for any quiz that's on Monday. You're ready for the homework, too. I'd just be careful, because if you don't write that ICE thing, then this sometimes you might give the wrong answer here.
So mine is a 14, right?
Yeah, but see, in the other one, you don't. Yeah, here the other one it's minus the 14 if you calculate for hydroxide.
So I have a question. How do you know, like, for sure it's K or KB?
That's why I think you pretty much have to, Jose. For me, I have to write this, because then when I get my X, I know what it is. That otherwise you go through all this work and you could just wasted all your time. Oh, you got the last one too? Man, I should have wrote more questions. There's no more? Man, you blew me away. You still didn't write your reaction though.
See, because I already know how to do it. It's just the fact that the KV or KA is the thing where I have to like flip it over. Because see, normally I would just do that, not like what this is now, but I take the KV and put it there, but it's wrong. So if it's this, then it's just fine.
Yeah.
Like I know how to do it now. It's just that I forgot these.
Yeah. It's just you're playing a little bit with fire there, but it works for you, I guess.
This all goes up here. I didn't realize it was just wrong.
Oh, okay, good.
Like,
Good. Okay, yeah, because you're writing a KB reaction. Excellent, very good. Mm-hmm. So it has to be moles over liters. So you have to calculate it.
Yeah, so yeah, just ask more questions. All right.
But this number is not that number.
Oh no, I know.
Oh, okay.